So in previous sections we have seen that light not only behaves like wave, but by photoelectric effect and Compton effect explanation, we see light is behaving like a particle. So we see that waves behaving like a particle. So is it true that particles like electron and photon, they also have a wave nature? Do they also behave like a wave? So this was the question and this was the query, and there was a hypothesis given by de Broglie, a French scientist. And in de Broglie's hypothesis in 1924, it was given that matter also, or the material particle like electrons, protons, they also behave like wave. They also have a wave nature. So by de Broglie's hypothesis, it is given that the wavelength of any material particle is given by this lambda is h by p. P is equal to m into v, which is the momentum. So any particle, if it is moving, if it has certain velocity with which it is moving, or material particle which has momentum, then they will have a wave which we call it as matter wave or de Broglie's wave. And the wavelength of such particle is given by lambda equal to h by p. Now, as we know that suppose the kinetic energy of certain material is half mv square, which is moving with the velocity v and with the mass m, and the kinetic energy is k, and therefore we can write from here that m square v square is 2m into k, and then mv will be root over of 2mk. From here we have just multiplied with m both side, m square v square, and 2 we have got here, so 2mk. So mv equal to 2 root 2mk, and if you just substitute here, you will get this as h by root 2mk. So this is the formula to calculate the wavelength of any material particle that is moving with certain velocity v. Now, when we have tried to calculate the wavelength of the material particle, we see that for a large mass particle or the heavier particle, even for a particle which 0.1 kg or 0.1 gram or something like that. So if such particle also have huge mass, and if the mass is more, then what happens, the lambda or the wavelength of such particle or such material particle that we can see with eyes and all, their masses are so huge that their wavelength becomes very small. And since their wavelengths are very small, it is very difficult to calculate. The wavelength is of range of 10 power minus 34 meter, which is very small, and therefore there are no existing instruments by which, or no existing techniques by which you can calculate such small amount of wavelength. You can only just calculate by your mathematical expression, that's all. You cannot really measure with any measuring instrument, and you cannot see such small wavelengths. So it is very difficult to kind of see or see the impact of the wave of this material particle which are heavy. Now, if we are going for a very small light-weighted particle like subatomic particle like electrons and protons and all, what we do see their wave nature. And for a subatomic particle, their wavelength or the matter wave or wavelength or de Broglie's wavelength is around 10 power minus 10 meter, and this is a very measurable amount with the various modern technical instruments. We can study about such wavelength, and in the experiment, Davison, Germer and all, in their experiment, and G.P. Thompson, in their experiment, they have proved, they have found the existence of the matter waves or the de Broglie wave in their subatomic particle. So with this, what we see that the subatomic particles wave is very much existing. It means that all the matters, all the particles, as we know, all the matters are made up of small particles called atoms, and these atoms are made up of very small subatomic particles like electron, protons and others. So this all part of they are the one which makes the matter, whereas the waves are the form of energies, and they are the form of radiations. So what here we see, the material particle have wave-like nature. They have a wavelength, and they have a wave-like nature, while they also have particle-like nature. And also waves like light waves and other electromagnetic waves, they also have a particle-like behavior, which we see as a photons, and they behave like particle in experiments like photoelectric effect, Compton effect. So what we see, both matter as well as the radiation have this dual nature of matter as well as radiation. So that is why it is called that the dual nature of matter as well as radiation. So everything, both wave as well as particle, have such dual nature.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.